This video will explore parts C and D. The scatterplot below shows the relationship between the top speed of a roller coaster and its track length. The pink dots represent wood frame roller coasters and the blue dots represent steel frame coasters. So this time we're looking at track length, and still we're looking at speed on the y-axis. Suppose you drew one linear model for the data in the graph. Could you use this model to make an accurate prediction about the top speed of a roller coaster with a given track length? So again, I'm going to draw a line through my data points. And mine will look something like this here. Do you think there is you can make an accurate prediction about the top speed based on that line? Number 2, estimate the correlation coefficient for the top speed and track length. Is it closest to -1, -0.5, 0, 0.5, or 1? And is the track length of a roller coaster likely to be one of the causes of the top speed of the coaster? So as the track length goes up, what does that tell you about the speed? Is the track length a part of the top speed? Section D says the scatterplot below shows the relationship between the top speed of a roller coaster and the ride time. The pink dot represents wood frame roller coasters and the blue dots represent steel frame coasters, just like the previous two. Suppose you drew one linear model to all the data in the graph. Could you use this model to make an accurate prediction about the top speed of the roller coaster with the given ride time? Okay, again, I'm going to draw a linear model through here. Using that line, can you make an accurate prediction about the top speed with a given ride time? Again, is it closest to -1, -0.5, 0, 0.5, or +1? And then question 3, suppose most of the points on a scatterplot cluster near a line, with only a few that don't fit the pattern. The points that lie outside of a cluster are called outliers. Use the graph above, find each of these points, then decide whether the point is an outlier. If it is, explain why you think it's an outlier. So 1.75 and 50. I'm going to find 1.75, which is in between 1.5 and 2, and 50. Looks like I have a point right here. Is that an outlier? Does it lie outside of a cluster? Next one is 0.3 and 80. 0.3 and 80. Does this point lie outside of the cluster? Is that an outlier? And do the same thing for the next C, D, E, and F. And the last question in this section says, use the scatter plot in question C. Find 2 outliers on that graph and estimate their coordinates. So looking for the outliers that weren't found in the last question, estimate their coordinates. The ones that are not close to any of the clusters. Those are outliers.